Algebra guys. I had you do perimeter and area, but now I want to go back and take a look at just looking at two-step equations or multi-step equations. The first thing you're going to do is distribute or collect like terms. If they're there, I guess I should say if necessary, right? Sometimes it won't be there. Sometimes you'll just have a two-step equation just like you see here, right? And then we could start right away. And as always, we still have a goal of isolating that variable, right? ISO the variable. Whew, horrible writing, all right? But I want to go ahead and use this 3x plus 10 here equals 1. And I want to look up here. Is there any distribution or do I have any like terms on one side or the other side that I need to put together? Right, I'm not going to add across here until all my terms are together. And I have 3x and I have 10. I'm not allowed to put those together. So everything's in order and ready to go. So the next step says undo the addition or subtraction. So to isolate this variable, I need to get this out of here, just like we did before. But before we only had 1x. Now we have 3 x's. Okay, so I have plus 10 here. I'm going to do the opposite of it to undo it. So I'm just going to subtract 10. Well, the subtraction property of equality says I have to subtract the same amount from both sides. So plus 10 minus 10, that goes away. I'm left with 3x on this side. There's my equal sign. Should be right underneath the other equal sign. And positive 1 minus 10 means I have negative 9. Well, now I'm down to a one-step equation. And my next job is to undo this multiplication or division. Well, I can only undo multiplication with division. And remember, we use a fraction bar to show that. And I put the 3 under it because I want one lonely little x. So I want to divide by 3. And 3 divided by 3 is 1. And if I divide over there, I have to divide over here because that's what the division property of equality states. I have to do it to keep this thing equal. So I have x equals negative 9 divided by 3. There's only one negative there, so this whole thing is negative. Negative 3 is my answer. Whee! So here's the same type of equation. Unfortunately, we have a little division here, and we'll undo the division next. But like before, there are no like terms that need to be collected. I can just get started with step 2. So I'm going to undo my addition. That's what step 2 says. Undo my addition with subtraction. So plus 8 minus 8. That's going to go away. Well, if I subtract 8 here, I have to subtract 8 over here. All right, 9 minus 8 is 1. And I'm left with a divided by 5 over here. And you put the equal sign right underneath it. And now I have to move on to step 3, which is undo or show the opposite of that multiplication or division. So right now a is being divided by 5. So what's the opposite of division? That's multiplication. Times 5 gets rid of division by 5. And then multiply by 5 over here. This leaves me with just a single a. And 1 times 5 is 5. There's our answer. It can be difficult and it might be annoying, but I think you can get through this. A couple more examples. Here they are. Sometimes they'll put the variable value on the right. This gets to be confusing because you see subtraction, but that's not what we're looking at. Collect like terms. Or distribute. Undo. Addition and subtraction. And then undo multiplication. Multiplication or division. Okay, let's go ahead and try this. Now, this is a little bit annoying. We could rewrite this if we wanted to, or we could just work on this. I'm going to show you how to just work on this because we don't want to undo this subtraction first. We want to get rid of this constant here, this 18. Because we have our variable value here, and the variable value is negative 2q. It's not minus 2q. It looks like minus 2q, but if you think of it as negative 2q, and this is a positive 18 out here, I think you're going to be able to get a lot more out of it. Get used to seeing minus as a negative with a little addition symbol in between. You know, if this is plus a negative, that's the same thing as subtracting. This is plus a negative. It's the same thing as subtraction. So let's go back over here. I want my negative 2q all by itself over here. So I'm going to show the opposite of positive 18. What's the opposite of positive 18? Negative 18. Well, that goes away. And if I showed negative 18 over there, I'm going to show negative 18 over here. What is 4 plus negative 18, or 4 minus 18? That would be negative 14 with an equal sign and a negative 2 times q. Now this addition and subtraction has been taken care of. My constant has been taken care of. I just have my variable value over here. Now I can do the rest. How do I undo multiplication by negative 2? I divide both sides by negative 2. Show that division bar. Negative 2 divided by negative 2 is 1, so I have a q left over. Negative 14 divided by negative 2, two negatives make a positive. Therefore, q is equal to 7. That's probably one of the more annoying types of problems they're going to throw at you in this section, just to keep you on your toes. This one's a little bit easier. It's subtraction. We could just think of it as subtraction in this case because it's not the variable value that's being subtracted. We have 3j minus 20 equals 16. We could say it's 3j plus a negative 20. That's the very same thing. And then get rid of this addition or subtraction. The reason I don't like to say plus a negative 20 is you're going to undo this subtraction with addition. So basically what you do is you just show the opposite sign and the value. Minus 20 plus 20, or negative 20 and positive 20. Got to put a positive 20 over here. So now we have 3j is equal to 20 plus 16 is 36. We have a little bit more work to do. We have 3j equals 36. j is being multiplied by 3. We're going to undo our multiplication or division. We're going to undo our multiplication with division. So 3j divided by 3 and 36 divided by 3. 3 divided by 3 is 1. So now I have one lonely little j over here. Here's your equal sign, and 36 divided by 3 is 12. There it is. There are a couple more difficult problems on your practice page, but to look and see how I do this vertical math is really what I wanted you to see. So good luck to you. I'll come over and see how you're doing.